Fine. So I am doing the paper. Okay, and this is November 2014, 22. Okay. Now, okay, done, bro, no problem. Ajay, Irfan, can you read the question, please? Yes, Irfan.
The Young modulus of the metal wire is 1.8 into 10 to the power 11 Pascal. The wire is extended and the strain produced is 8.2 into 10 to the power negative 4. Calculate the stress in gigapascals.
Okay. Can you tell me the formula, please, that relate the Young modulus stress and strain?
Yeah, stress over strain, and you
Okay.
just rearrange to make stress the subject.
Fine. Perfect. Okay. So 1.8 exponent 11 times it by 8.2 exponent negative 4 gives me the stress. Okay. How much? Yes. One, two, three. So I am getting 0.15, 0.15
One
gigapascal.
1.476
1.4 exponent,
6.
exponent 6. But we want in gigapascal, which is exponent 9. So you have to shift 3 point before, or just press shift and press ENG button. So it will make 0.1476 exponent 9. Okay. Clear? Fine. Okay. Electromagnetic wave has a frequency. Okay. Irfan, can you tell me the speed of the electromagnetic wave? Yes.
3.0 into 10 to the power 8.
Good. And the conversion factor of Tera? Yes, how much? Tera is 12.
I'm not sure. Wait.
Okay, yeah, it's 12. Giga is 9. Mega is 6. Kilo is 3. Tera is 12. Okay. And that will give me the lambda. Okay. Please calculate. I'm getting, I'm getting 25 micrometer. We want exponent negative 6. Okay. So that's 25. Okay. Is that clear, guys? Yes, you have to be quick. Irfan.
Yeah.
Hmm.
Yes, sir.
Okay. Irfan, next part, please.
Say the name of the region of the electromagnetic spectrum for this frequency.
Hmm. So you also have the wavelength, by the way. Okay. And exponent negative 5 or negative 6 mean it's supposed to be the infrared radiation. Okay, clear? So infrared radiation, right? So okay, fine, let's move on.
An object B is on a horizontal surface. Two forces act on B in this horizontal plane. A vector diagram for these forces is shown to scale in figure 1.1.
Okay.
A force of 7.5 Newton towards north and a force of 2.5 from 30 degrees north of east acts on B. The mass of B is 750 gram. On figure 1.1, draw an arrow to show the approximate direction of the resultant of these two forces.
Okay, so the resultant of these two forces would be maybe in this direction, or just an approximation. Okay, because the vertical force has a greater magnitude than the other one, so that's why the resultant should be more tilted toward the vertical, right? and this should be R. But that is basically the resultant of these two forces shown, right? There is also a mass involved, right? So you have to be very careful with the mass as well. Okay. Now, if you just redraw the whole thing, so that is the object. We have this force acting, okay, with 2.5 Newton, 2.5 Newton at an angle of 30 degrees, okay, at an angle of 30 degrees. And now we have the vertically upward force. अबे यार एक तो सीधी दे दो ना यार. So we have the upward force. Okay. Now you know that 7.5 is actually acting upward, right? And the weight is 750 or 0.75 into 9.81, right? And that will act downward, okay? So what will be the resultant? 0.75 into 9.81 giving me 7.357, okay? 7.357, okay? And um the magnitude of the resultant force on B. But we have to consider that, yes. So if we just subtract, so 7.5 minus answer, so I am getting 0.143, 143 as the upward force. Mm-hmm. But that won't give me. Okay. So if I just make the components, so this component will be 2.5 cos 30, and this will be 2.5 sine 30, right? And this is downward. So I think we don't have to consider the weight. The mass at B, okay. horizontal surface है सही है. अच्छा वो उन्होंने just दिया हुआ है a force of this toward the north, so you don't have to consider the mass then. तो वो फायदा नहीं होने वाला. सही है. So now you have the horizontal force. So okay, so Rx is just 2.5 cos 30, and Ry will be 7.5, which is upward force, minus 2.5 sine 30, right? So just calculate the value. So 2.5 cos 30, that gives me 2.1165.
2.165.
Perfect. And what about the other one? 7.5 minus 2.5 sine 30, 1.25, and 6.4, 6.35. I think. Yes,
6.25.
6.25.
Two
Sorry.
five sir.
Okay, okay. 6.25. Now, we know that for the resultant, it should be under root rx squared plus ry squared, right? So 2.165 squared plus 6.25 squared, and just root it. How much?
6.61.
6.6.
6.61.
Okay, okay, just that's fine. 6.6 because we have to show 6.6 Newton. Okay. Ajay, just for the confirmation, I am checking the examiner report. अच्छा जी. Many candidates drew incorrect arrow for the direction of the resultant. A significant number gave an arrow in the opposite direction to that required. Okay. There were variety of the method possible to show the value for the resultant for those that uses a scale diagram often lost credit by not including a scale. Okay. So if you are drawing the scale diagram, you have to write K. You are considering this much centimeter equivalent to that much amount of force. Okay. A significant number of candidates successfully use either the cosine rule or the resolution of the force and then Pythagoras theorem. Okay, so I use that. Chalo. So they're saying magnitude of the resultant force. So we have the resultant force. Which formula you use this one? Yes. So 6.6 divided by 0.75 equals MA. Okay. So how much?
So 8.8.
8.8. Fine. Okay, G. So moving on to the last part. Determine the angle between the direction of the acceleration and the direction of the 7.5 Newton force. Okay. So direction of acceleration should be the direction of the resultant force. Okay. And that is what we draw in this direction. Okay. So this is the direction of acceleration. Okay. Sorry, this is the direction of the resultant force and the direction of acceleration, right? And they're saying the from 7.5 Newton force. Okay. So this is the angle that we have to find out. Okay. So this is R. Okay. So agar if you just work out for this angle, okay, then it will be just you just need to add it by 90. Okay. So for that um, you can just do tan theta tan theta and is equals to ry over rx. Okay. That is ry is basically 6.25 and rx is basically 2.165. 165. Okay. So when you take the tan inverse of the value, you will get how much? Yes, anybody doing? Theta. Okay. And
Sir, 70.9.
70.9. Okay. And then add it with 90. So you will get 160.9, right?
Yes.
160. The direction of the axis and the direction of 7.5 Newton force. Um, 160.9. Okay. Yeah, but we are supposed to take the clockwise direction, na? So we should have to consider this angle, not that the other angle. So it should either be 160.9 or it would be either if you subtract it by 90, 90 minus 70.9, that would be 19.1. So 19.1. So either of the two answers are possible. Okay. So this is from the vertical and this is from the downward force. Okay. But let's see what they're quoting. They're saying 19. Use of the scale diagram. Okay, okay, okay. We got 8.8. Yes. Okay.
Sir,
And
but
if we
how will we know if you have to use clockwise or anti-clockwise?
actually एक मिनट बताता हूँ एक रूल है वो बता देता हूँ but मुझे just ये देखने दो. Majority of the candidates found it difficult to calculate the correct angle. There were a number of different approaches possible. Candidates should be encouraged to draw a sketch vector diagram to help with this kind of analysis. Okay. So basically, the rule over here is Whenever you have to find out the angle, and if they didn't mention anything, or they're just mentioning the direction, so always pick the anti-clockwise direction, right? Because we don't have, or we don't have to take the clockwise direction into account, right? So like the basics of to find the angle is to take the positive x-axis and you have to go like this, okay? Like this. So so this is always the rule, okay? Or this will always be the rule, okay? But since they have given you this as a reference plane or as a reference line, so you have to go to this point, okay? Clear? Yes. Yes, ma'am. Okay, so that should be this one. चलो. Okay, done. आज भी. Irfan, नहीं. Ryan, can you please read the question?
A ball is thrown from A to B as shown in figure 2.1. The ball is thrown with initial velocity v at 60 degrees to the horizontal. The variation with time t of the vertical component of the velocity of the ball from t equals 0 to t equals 0.6 seconds is shown.
Okay. अच्छा. Can you tell me what is this point, or what this point will be, or where this point will be in the diagram? Yes.
Sir, can you show the graph?
Hmm.
So this will be the maximum height.
Maximum. But for the projectile motion, the maximum height will always have the horizontal velocity, no? Yes. Any
Yeah,
idea?
but sir, they've shown a vertical component.
Very good, very good, very good, very good. So there, since they're asking you about the vertical component, so that's it. Perfect. Okay, let's move on.
Assume air resistance is negligible. Complete figure 2.2 for time until the ball reaches B.
Okay. So the time, okay. So if zero point 0.6 required for the maximum height, so there will be the same amount of time required for the ball to come back to the same point. Okay. But it is not starting from 6, so you're not allowed to end at 6. Okay. It's just ending at 5. Okay. 5.9 psi per second. Okay. So this is what you have to make sure. Clear? Let me show you the examiner's report. Okay, the
Yes, sir.
majority of the answers were correct. There were some answers that gave the velocity at B at this instead of minus 5.9. So we have to show minus 5.9. Okay. Okay, let's move on. आगे read कर दो. Yes, Rayan, कहाँ हो?
Calculate the maximum height reached for the ball.
क्या करेंगे भाई? Which quantity from the graph helps you out in that? Yes, will it be the area? Will it be the gradient? Yes, Rayan,
So the area
the area. And
under
from
the
which point to which
top
point?
triangle.
Top triangle. Perfect. So, so height आप लिख दोगे. Max height equals to area under the area under the graph till t equals to 6.6 seconds. सही. Now 1 over 2 into height आपके पास है 5.9 into base आपके पास है 0.6. जरा निकाल दो. How much?
1.77.
1.77, so 1.8 ले लेते हैं. Okay, let's move on.
Calculate the horizontal component Vh of velocity of the ball at time t equals 0.
Mm-hmm. Hmm. So vertical component at time t equals to 0 is 5.9. The angle is 60. So what will you do? So
5.9 sine 60.
abe, 5.9 is not the resultant velocity. It is a vertical one. You don't know
Oh,
this
we have to find
velocity.
result.
Yeah. You don't have to just apply apply the tan theta, no? You'll get the answer. Getting?
Yes, sir.
Okay. So tan theta or tan 60 equals आपके पास हो जाएगा um 5.9 divided by VH.
It's a 3.41.
3.4. Okay. 3.4. Fine. Okay. Let's move on.
Uh, on figure 2.2, sketch the variation with T of VH. Label the sketch VH.
Okay. How will it be? Yes. So at 3.4, just draw the horizontal line. ये मत कर देना, okay? The motion is not ending at 1.4. It is just till 1.2, okay? So be very careful, okay? So if the
Okay.
student carelessly draw till the end, they lose mark, okay? So and just write 3.4 and that is VH. Let me show you the marking examiner board. Significant number of velocity, HG. A small minority candidate obtained the correct answer. Many of the incorrect answer was okay. HG. Very few candidates obtained credit. A significant number did not give any response, even that they had answer to part 3. Okay, वही इसी चीज को plot करना था. Some of the candidate who did drew a line of the constant velocity continue it past 1.2. देख रहे हो ना रेयान, देख रहे हो ना? So you're not allowed to continue it past 1.2.
Yes, sir.
You should have to stop it at 1.2. Fine. ओके जी, आगे आ जाओ.
The ball has a mass 0.65 kg. Calculate for the ball the maximum kinetic energy.
Hmm. So half mv squared, right? 0.5, which is half into 0.65 into v square, the maximum kinetic energy. Okay. Which velocity do we take for the max kinetic energy?
Sir, horizontal.
Horizontal. Why horizontal? Any reason?
Because horizontal component is not zero.
Come on. Acha, by the way, what do you mean? What they mean by the maximum kinetic energy? Will that be at the top? Will that be at the starting point, or where it will be
At the last point before hitting the ground.
before hitting the ground? Or if you say just at the point of launching, would that be correct? Yes.
Yes.
Okay. So for that you should have this velocity v, which is the resultant velocity. Okay. Right? Because
Okay.
maximum for the maximum kinetic energy, you require the resultant velocity, and resultant because of energies are directionless, right? So this was 3.4 and this was 5.9. Just apply the Pythagoras theorem to find v. How much?
4.82.
4.82 नहीं आना चाहिए ना, ज्यादा आना चाहिए बे. It should be greater than
Oh
6.
wait, sir, I did
माइनस नहीं करना है ब्रो, प्लस करना है.
6.8.
6.8 सही है. ब्रो हाइपोटेन्यूज बड़ा होता है ना सबसे, तो दैट इज वाई.
Yes.
Okay, 6.8. Just put 6.8 here. Okay, and square it, and you'll get the value. By the way, you have to show how you end up getting the resultant velocity. Okay, let me
Okay.
just draw. Guess how much?
15.02.
15.02. So 15. Okay, G, fine. 15. Perfect. Okay, the maximum height, the maximum potential energy above the ground. Okay. So maximum potential energy required maximum height. Or for maximum height, we know that the maximum height is 3.4. Okay. So mgh. So yeah, the mass of the ball is 0.645, and maximum height would be 3.4. Okay. It is 3.4. Yes. हाँ जी कितना आ रहा है?
21.7.
21. पक्का.
Yes, it's 21.68.
8. The maximum height reached by the ball is. अच्छा sorry 1.8 लेना है ना हमें. I'm sorry. It should be 1.8.
11.5.
Okay. चलो. Okay. Done. Let me see. They're getting 11. Okay. They have used the previous answer. Okay. They're not rounding that off. Fine. Electric field is not a part of the syllabus. You can skip that. This is also not the part of the syllabus. Okay, so ductile material. So for the ductile material, you should know the graph should look like this, and then it eventually breaks. And sorry, गलत हो गया, गलत हो गया. So that was for the brittle one, ना? Ductile के लिए ये बताया कि बस. Elastic limit. So this is the limit of proportionality, then elastic limit, and then it goes up, and then it comes down, and then it breaks. Okay. While for the case of this one, brittle. Okay. So ये curve बहुत ज़्यादा हो गया. So just. So this is the brittle graph looks like. Okay. Ductile and brittle. Okay, so ductile and brittle both have both obey the Hooke's law for a certain limit or till the limit of proportionality, and जो difference है वो आपके पास जो है ductile will break away, right, um, after the limit of proportionality, but brittle. अच्छा जी लिख लेते हैं. Similarity में हम कह रहे हैं कि both obey the Hooke's law. Okay, so both obey the Hooke's law. द हुक्स लॉ. सही है. और हम ये कह रहे हैं कि टिल द लिमिट ऑफ प्रोपोर्शनैलिटी. सही है. एंड जो आपके पास डिफरेंस है, यू कैन से दैट ब्रिटल ब्रेक आफ्टर स्मॉल एक्सटेंशन. ओके, फाइन, डन. चलो भाई आ जाओ. इमाद, आर यू देयर?
Yes, sir.
प्लीज रीड द क्वेश्चन.
A battery of electromotive force 12 volts and internal resistance R is connected in series to two resistors, each of constant resistance X as shown in figure 5.1. The current I1 supplied by the battery is 1.2 amps. The same battery is now connected to the same two resistors in parallel as shown in figure 5.2.
Okay. So, okay, fine. The first one is a series circuit, second one is a parallel circuit. Okay.
The current I2 is supplied by the battery is 3 amps. Show that the combined resistance of the two resistors, each of resistance X, is 4 times greater in 5.1 than 5.2.
Mm-hmm. So, what you can do, so they have, okay, so if you have the same battery, so 12 and the internal resistance remains the same, you are using the identical resistor, so the resistance of the identical resistance remains the same, right? So we can say that 12 is equals to I1, okay, times 2x plus R, okay? And for the second case, we can say that 12 equals to I2 times x over 2, because you have 1 over x plus 1 over x, 2 over x, and x over 2, right? Plus r, okay? Now, we know that we know that I1 is 12, 1.2 times 2x plus r, okay? So when you divide it there, so you'll get 10, right? 2x plus r, okay? And I2 is 3. I2 is 3. So when you divide, you'll get 12 over 3, 4 equals to x over 2 plus r, right? Now, just make r the subject from both the equation and substitute. So 10 minus 2x equals to 4 minus x over 2. Okay, now you can simplify it. They're saying the resistance of the two resistors. Okay, so this was the series resistance and this was a parallel one, right? So I have to differentiate it because we have to relate it at the end. Okay, so 10 minus 4 equals 2xs minus xp over 2, right? So that would be just 6. Okay, and अब यार हम वोल्टेज से क्यों कर रहे हैं? Show that the combined resistance of the two resistors, each of the resistance 4 times the greater. So 4 के फैक्टर कहाँ से लाएंगे हम? Okay, so 6 equals to 4xs minus xp divided by 2. Okay, so that would gives me 12. अरे यार, आसान सा क्वेश्चन है, ये गलत हो रहा है. Show that the combined resistance of the two resistors, each of the resistance x, combined resistance of the two resistors.
Sir, why don't you just assume values and
अरे
we can
यार,
find for
है ना? So if we have the figure 5.1, so in the figure 5.1, the total resistance, excluding, not including, excluding the internal resistance. So total resistance is 2x, okay? And in 5.2, the total resistance is just x over 2, right? So if we just relate, so like if we just relate, so this is the series one and this is the parallel one, okay? And if you just find the ratio, so it would be सही हो गया, ये आ गया. अच्छा, उसके बाद जो है, so 2xs over xp over 2, right? So that would give me, अच्छा जी, resistance of S over the resistance of P. Hmm? So you 4xs divided by xp. Okay. And we can say that K series has 4 times the greater resistance. Okay. So 4xs, which is a series, is equals to xp, which is a parallel. Okay. So आपने hence um, parallel has 4 times lesser resistor, right? Acha, by the way, if we just check the marking key, mm-hmm, fine. So हमारे पास आ रहा है, you're also not saying anything or no, they're not showing any calculation. So 6 majority candidate credited for similarly by referring to the transfer of the energy. The answer for the sorry 5 है. The working for this show that question was generally not well presented. Okay, the two required values are often stated without any reference to any particular circuit. The majority of the circuit, the majority of the candidate obtain partial credit for the series combination. The answer for the parallel combination was often incorrect as the following incorrect calculation: 1 over total is 1 over R1 plus 1 over R2. अच्छा जी, in comparison between the total resistance the two circuits or the inappropriate statement was made. हमने भी तो यही बनाई है. यार सही है, क्या कर सकते हैं इसमें. Explain why I2 is not 4 times greater than I1 because you have the internal resistance, right? So चलो, so internal resistance or yeah, is not 4 times. Okay, it is rather same as the batteries as the battery is same in both the circuit. चलो, डन हो गया, आगे आ जाओ के बाद.
Using Kirchhoff's second law, state equations in terms of EMF, current X and R for the circuit of figure 5.1 and the circuit of figure 5.2.
अच्छा जी, ईएमएफ और करंट की टर्म में बोल रहा है. सो फिगर 5.1 आपके पास, अच्छा इसकी ज़रूरत नहीं है, बाय द वे इसको हटा देते हैं. हम्म. सो यहाँ पे ईएमएफ जो होगा वो किसके बराबर होगा? I1 टाइम्स 2x प्लस आर, राइट? ऐसे ही ना, जैसे माधुरी से.
So this is the formula for internal resistance.
नो, इट्स जस्ट द किरचॉफ लॉ. V equals to IR. So the total voltage सही है, the total voltage E of the battery drop across this and this. Okay, so I just add all the resistances and there's a current, right? Clear? And for this one, the total voltage E, I2. Okay, and so the total resistance for these two would be just R over X over 2, right? So X over 2 plus R, right? Is that clear?
Yes, sir.
So okay. So we have E1, I1, 2x plus R. Okay, and we have E2 equals to I2 and then x over 2 plus R. Okay, आगे आ जाओ.
Use the equations in 3 to calculate the resistance X.
Hmm.
Sir, for which circuit we can use any?
Use the equation in party to like x remains the same, yeah, because the resistance are same, right, for both the circuit, but the overall effect would be different because the combinations are different, right?
Sir,
Clear?
but if we use series, it will be easier.
No, just use both of the equation to get the value, right? Like if I substitute E1 and E2 in it because both are same, right? So I'll get I1 times 2x, right, plus R, and equals to I2 times x over 2 plus R, right? This is the case. Okay. Since E1 and E2 are equal, right? You have to make the statement or make the reference. Okay. Since E1 equals to E2, right? Now, so I1 was, I think 1.2, I think. I1 is 1.2, and 2x plus R equals to I2 is 3, and x over 2 plus R. Okay. So, can we directly ignore the internal resistance, or I think so. If we use, acha, by the way, we know that there's a relation between x and 4x, okay? So we have to use that as well. Wait. अच्छा ये वहां पे हमने ये यूज कर रहा था. Okay. And क्या कर सकते हैं इसका? So expand कर लेते हैं, but we will have two unknown, and if we have two unknown in the equation, so I don't think so we will get the answer in a equation. Okay, so maybe this won't work for us. हमने जो है ना वो इसको डायरेक्टली सॉल्व करना पड़ेगा ऐसे ही. So 12 equals to 1.2 into 2x plus r. This is the first equation for the first circuit, and 12 equals to 3 time over x2 plus r. Right, this is the second equation. You have to do that way. Okay, so that will give you 10 equals to 2x plus r, and then 4 equals to, or just take the LCM, so you'll get 2r times 8. Okay, and now you have two equations, just solve them simultaneously, you'll get the answer. Okay, you can just put it in the calculator as well. So, or make r the subject and just solve. So 10 minus 2x equals to 8 minus x over 2 equals to r, right? So 10 minus 2x equals to 8 minus x over 2. Okay, so that would be 20 minus 4x equals to 8 minus x. Okay, and that would be 5. So 20 minus 8 equals to 4x minus x. Okay, so 12 divided by equals to 3x. Okay, so x equals to 4. Okay, भाई समझ लो. Any problem, guys? Any problem? Anybody? Yes, please say something. Yes, Imad, Irfan, Rayan.
Sir, can you go up? I'm going to take screenshot.
Okay,
That's it.
okay. Now please move on.
Calculate the ratio power transfer in one resistors of resistance X in figure 5.1. and the power transformed in one resistor of resistance X in figure 5.
Okay. So we have the current, we have the resistance. Okay. So can you use V is power is equals to I square R, right? You are not allowed to use the formula V square over R because you don't know the internal resistance, and so you also don't know the voltage loss across the internal resistance, right? So you would get stuck. Okay. So the ratio of, so यहाँ पे हमने ले लेना है I1 times R I square R power transfer in one of the resistors. So that has a resistance of 4. Okay. And I2, okay, and that also has a resistance of 4, but if the current in the second circuit is 3 amperes, so at this point there will be the current of 3.0, but at this point there will be half the current upward and half the current downward, right? Because of the equal resistances, right? So the current will be half. Okay, so you have to take half the current. Okay, I2 divided by 2. Okay, so just solve it and you will get the answer. Okay, so 4 and 4 goes off, and I1 is 1.2 squared. I2 is 3 divided by 2, 1.5 squared. Okay, and is how much? This is equals to ratio. Yes, anybody doing? 1.44 divided by 2.25.
0.64 RSF.
0.64. Okay, let's see. Points. क्या बात है यार, हैवी हो गया, टाइट. ओके, क्लियर है? एनी प्रॉब्लम? Okay, let's move on. Imad?
Resistors in figure 5.1 and 5.2 are replaced by identical 12-volt lamps. Explain why the resistance of each lamp when connected in series is not the same as the resistance of each lamp when parallel.
Yes. What is the characteristic of filament lamp? Will there, um, is it, mm, okay. Will its resistance be constant as the current flows through it? Yes.
Um, so it isn't filament lamp depending on the
The current basically. So if you have the higher current, that causes the more heating effect, and more heating effect mean increasing in the resistance. So you'll have lesser or greater resistance, right? Due to the current, right? So you can say that the resistance of filament lamp is um, related with the current, or is varies with the current, varies with the current. सही हो गया. So now, so if you consider the series circuit, so in series circuit you'll have the lesser current. So lesser current mean lesser resistance, lesser heating effect. So it will end up giving you lesser resistance. Okay. So in series circuit, lesser resistance. Sorry. Uh, lesser current. Um, flow through it. So lesser heating effect, and hence the lesser resistance. Okay, then in parallel. Okay, so in parallel you'll have the greater current causing it a greater resistance, and greater heating effect, and that causes the greater resistance. Okay. Okay, so let me just see the examiner's report. Very few candidates able to explain the resistance of the film lamp depend on the potential difference across the lamp. Okay, I explained using the current. Let me see, is it acceptable? Okay, V or I is greater in parallel. Okay, I said I is greater in parallel. V or I is lesser in series. Okay, you can either give one or any of the statement. Okay, fine. Chalo, done. Okay, Irfan, are you there?
Yeah,
Okay, please read the question.
I need to leave though because I have another. The
The
class
class
already
started.
started half an hour back.
Okay, okay, you can leave. Okay,
Okay,
then
thanks, sir.
bye. अच्छा जी रेयान आप रीड कर लो.
State one difference and one similarity between longitudinal and transverse waves.
Hmm. Yes.
So in longitudinal, um, it is the particles is parallel to the motion
Okay.
of the wave.
So you say that okay in longitudinal wave particle you have to be precise. Okay, particle move या oscillate parallel to the direction of energy transfer, right? And
Yes.
if you write right in in transverse wave in transverse wave particle oscillate perpendicular to the direction of oscillation. Okay. Okay. And what about the similarity?
Both transfer energy.
Both transparent. Okay. Transfer energy. अच्छा जनाब
A
चलो.
laser is placed in a laser
Mm-hmm.
is placed in front of two slits as shown in figure 6.1. The laser emits light of wavelength 6.3 exponent negative 7. The distance from the slits to the screen is 2.5 meters. The separation of the slits is 0.35 millimeter. Any interference pattern of maxima and minima is observed on the screen.
सही है
Explain
जनाब.
why explain why an interference pattern is observed on the screen.
Okay. So you have to show the constructive like you have to talk about the phase difference and part differences. Okay. Okay. Yes. क्या कहोगे?
So the two light waves superimpose and have constructive and destructive interference.
Okay. And चलो उसके लिए हम ये कह सकते हैं कि भाई लाइट अच्छा लाइट के बजाय द लेजर. ओके. So लाइट के बजाय हम वेव लिख लेते हैं, क्योंकि पिछले दफ़ा हमने मार्किंग एग्जामिनर रिपोर्ट में देखा था कि वो वेव का वर्ड रेफर कर रहा था। ओके, सो वेव
Okay.
फ्रॉम द टू solid um, produce coherently, okay, and um, and overlap overlap at the screen with path difference of n lambda and phase difference of n plus 1 over 2 lambda, sorry, phase difference of n times 360, right? And for maxima, right? And आप कह सकते हो कि भाई path difference is equals to n plus 1 over 2 lambda and phase difference of 2n minus 1 2n minus 1 times 180 shows for minimum, right? For minimum. Okay, just check the examiner report really quick. Okay, the majority of the candidate obtain the credit for the similarity by referring their energy. Okay, the different compare different direction of the vibration of the particle to the direction of the energy transfer are often too imprecise. Okay, Irfan, Ryan, समझ रहे हो ना? You have to be very
Yes, sir.
precise in that. Okay, comparison with the wave motion or the direction of the wave or common vague description. Okay. The answers, ये भी हमने लिखा, the answer was generally not of the required standard at the AS level. Many refer to the constructive and destructive interference. Okay, so this means you're not allowed to do so. Okay, you have to like you're not allowed to just make the reference of constructive and destructive interference. You rather have to tell them the conditions required for the constructive and destructive interferences, which are the phase differences and the part differences. Okay, so which is अच्छा
Okay.
जी, wave being in phase or out of the phase or crust meeting crust, a complete, okay, this is all not required. Many refer to the constructive and destructive interference, wave being in phase or out of the phase or crust meeting crust. These are not acceptable. Okay, a complete explanation required reference to the phase difference or the path difference needed for the maxima or minima. So you can write any, you can write for any one, right? Either you can pick for the maxima or the minima will be understood, right? So very few candidate mentioned that the slit produces a coherent wave, and that is this is a condition for the interference pattern to be observed. Okay, good. So this is the first thing. Yeah, I coherently. Yeah. So I mentioned the coherently, okay, and then they overlap at the screen. So always keep in mind, do not make the reference of the constructive and destructive interferences right away. Just make sure to write their condition, right? And the condition for the constructive interference is the path difference of this and the phase difference of n lambda, and for the destructive interference, this and this. Okay, since they're giving you 2 marks, so you can just write for either maxima or minima. If they give you 3 marks, then include both of them, right? Include for both. Okay.
Sir, can we write the light diffracts after passing through the slit?
Yes, but use the word wave in not light. Okay. But since it's a 2 mark question and they're only related to explain why an interference pattern is observed on screen, okay? So they're mainly related, they're mainly asking about the concept of the screen or about the things that you can see on the screen. So yeah, so you have to be particular with the screen, right? So you can just skip that diffraction from the slit, okay? But you have to make sure that the two waves are coherent, because if the two waves are coherent, then you will find the pattern consistent. Okay, like that. Okay, this is because of the coherency. Okay, so you have to mention the coherency. If the light is not coherent, so maybe you find like this. Okay, so if you're using the non-coherent light, so you will see the inconsistent pattern. Okay, so light should be coherent in order to have the equally spaced fringes. Okay, fine, let's move on.
Calculate the distance between adjacent maxima.
Okay, x equals to lambda d over s, yeah, over a. Okay, so they're asking for the x. Lambda is given as 6.3, 6.3 exponent 7, and d is 2.5 divided by a is the surface separation, which is 0.35 millimeter, exponent negative 3. चलो भाई कितना आ रहा है?
4.5 exponent -3.
4.5, 4.5 exponent negative 3. फाइन, तो क्या आ जाओ, आगे आ जाओ.
State and explain the effect, if any, on the distance between adjacent maxima when the laser is replaced by another laser emitting ultraviolet radiation.
Hmm. So if you're using ultraviolet radiation, would that be will the wavelength be greater or smaller? Quick.
It's a
Ultraviolet
greater.
radiation has a smaller wavelength, not greater. Okay. So ultraviolet has a smaller radiation, a smaller wavelength. Okay. So the distance between the adjacent maxima will be reduced. Okay. Clear?
Yes,
UV radiation has smaller wavelength. So separation between the fringes decreases. Okay. Imad, last question है आज जो read करो जल्दी से कोई.
In the decay of nucleus, PO and alpha particle is emitted with an energy of 5.3 mega electron volts. The emission is represented by the nuclear equation. On figure 7.1, complete the number and the name of the particle of particles represented by A and B in the nuclear equation. So A will be 206 and B will be 82.
82. Okay.
Uh, so A will be name nucleon number.
Okay. Um, nucleon number and B is the proton number. Chalo.
State the form of energy given to the alpha particle in the decay of.
Kinetic energy, it will start moving, right? Okay. Last part.
So it won't be nuclear energy.
No, nuclear energy is just for the weak nuclear forces are just for the decays, right? And after decay, when it start moving, so it will have the kinetic energy at all. Like all of the energy is in the form of kinetic, right?
A sample of polonium emits 7.1 exponent 18 alpha particles in 1 day. Calculate the mean power output from the energy of the alpha particles. Sorry, your mic is muted.
Yeah, yeah. अच्छा जी, मैं ये कह रहा हूँ कि हमारे पास जो है एक दिन के अंदर वी हैव दिस मच नंबर ऑफ अल्फा पार्टिकल, राइट, एंड वी नो दैट फॉर वन अल्फा पार्टिकल 5.3 मेगा इलेक्ट्रॉन वोल्ट एनर्जी is generated when one alpha particle is like is produced or is decayed. सही है. So you just multiply the two to get the total energy generated in one day by all of the alpha particle generated, right, from the decay, right? And this will be the total energy and you have to divide that by time. Okay, so the time for one day would be 24 hour into 60 minute into 60 second. Okay, so basically you have total energy divided by the total time. One day. Okay, chalo.
So you get 69.68.
69 points. Okay, 70 then 70. Perfect. Okay, that's it, done. So this paper is also done. So we are done with the November 2014. सही है, 3 साल के पेपर हमने कर लिए हैं अब तक. सही है. Now try the three variant of it, right? Um, 21 variant, 23 variant, and 21 variant and 23 variant. सही है. So this will going to be the May June, and this will going to be the October number. Okay, and both are from 2014. Okay. सो अगर तुम लोग में से किसी ने कोई किया हुआ है देन फाइन, अगर तो नहीं किया हुआ देन द होल वीक वी हैव टू डू ऑल ऑफ द 4 पेपर. एंड ब्रो ये सबमिट करना होता है. रयान, रयान सुन रहे हो ना?
Yes, sir.
सो आप कैसे भी कर रहे हो, आप कॉपी पे कर रहे हो, आप सॉफ्ट कॉपी पे कर रहे हो, आप हार्ड कॉपी पे कर रहे हो, कैसे भी कर रहे हो, जस्ट कंप्लीट द पेपर एंड मेक द पीडीएफ एंड मेक श्योर टू सेंड मी, ताकि मैं चेक करूँ कि उसमें क्या कोई गलती आ रही है. सही है, अगर कोई मुझे मिलती है देन आई मैं बता देता हूँ कि भाई ये गलती है, इसको ऐसे करो. सही है ना?
Okay, sir.
सही है. सो मेक श्योर टू सेंड मी द पेपर्स. ओके. एंड ये नेक्स्ट क्लास से पहले यानी नेक्स्ट सैटरडे से पहले यू हैव टू सबमिट ऑल द 4 पेपर, राइट?
Okay.
मतलब जब भी जो भी हो जाए बस आप वो फौरन फौरन देते रहो. सही है, तो मैं उसको चेक करके बता दे रहूँगा. सही हो गया. चलें जी.
Sir, I
चलें.
sent you one question. Solve.